This is how to separate different ions by precipitation. To what pH should a solution that is 0.015 molar in nickel 2+ and zinc 2+ be adjusted in order to best separate ions by precipitation of the hydroxides? And we're given the KSPs. Now, please notice that zinc hydroxide has the smaller KSP, so this is the material that's going to precipitate first, since it is less soluble. So your strategy is actually to find out when will the other one precipitate. That's actually your strategy to achieve the best precipitation. So, to figure this out, what I can do is take my KSP is equal to nickel 2+ times hydroxide concentration squared. And I know my KSP is 1.6 times 10 to the minus 14. My nickel is 0.015 molar. So I just would like to find my hydroxide concentration. And then I can get the pOH and the pH. So, putting that into my calculator, I get 1.03 times 10 to the minus 6 molar is equal to my hydroxide concentration. And taking the negative log of that, I get that the pOH is equal to 5.99, which means the pH is equal to 8.01. So, my task here is to run the pH just short to maybe 8.00. Why not? Okay? We're running it just short of where the second one starts to precipitate. So, I would put in 8 as my answer. You can choose what you'd like. You could go shorter if you wanted at 7.9, but, that's the best separation you would get. The next question asks, what are the concentrations of the metal ions after the pH is adjusted to pH equal 8? Alright, very well. Let us figure that out. For the nickel, the idea here is that it doesn't precipitate. So it should be equal to 0.015. But just for fun, let's check it, okay? 1.16 times 10 to the minus 14 is equal to my nickel concentration times 10 to the minus 6.00, okay, that's 10 to the minus pOH, that's my hydroxide concentration, right, I'm getting that from there, squared. Let me solve for the nickel concentration. And it turns out that it is equal to 0.016, which is cool. That is the amount of nickel that can be in solution. But of course, we only started out with 0.015, so that is really the proper answer. Okay, let's do the same thing for the zinc now. Zinc 2+ does precipitate, so we have to take the KSP is equal to zinc 2+ times hydroxide squared. My KSP is 4.5 times 10 to the minus 17. My zinc is what I'm trying to figure out because some of it is precipitated, and my hydroxide is 10 raised to the minus 6 squared. So let me do that math. And I get 4.5 times 10 to the minus 5th molar is my zinc concentration at pH equal 8. Okay, that's all there is to it.